This mini lecture is on tsunamis, scales, and earthquake safety. This is chapters 5.9 in your textbook. The next topic about earthquakes is about scales. There are two scales we're going to talk about. First is the Richter scale, and this measures magnitude, or how much shaking or energy is released by an earthquake. It's said that the scale goes from 1 to 9, but technically it does go up to 10. An earthquake about 2 or less cannot be felt. An earthquake the magnitude of about 7 can cause major damage. The largest earthquake ever recorded was a 9.5. The next scale is the Mercalli scale. This measures intensity. Intensity is how much damage is caused by an earthquake. This scale goes from 1 to 12 using Roman numerals. A 2 can be felt, but there's no damage. A 10 will cause damage to wooden structures, and railroads will be bent. A scale of 12 gives you total destruction. Now, the Mercalli scale can be tricky. You could have the strongest earthquake in the world, but if it happens in the middle of the desert where there's nobody around, on the Mercalli scale, it would be a Roman numeral 1 because there is no damage. Or another example, you could have an earthquake in a city that is not prepared for earthquakes, like the earthquake that happened in Haiti a few years ago. Their buildings were not built to withstand earthquakes, so they had a lot of damage. So even though that wasn't a very big earthquake, it had total destruction. So it rated very high on the Mercalli scale. We're not going to be using the Mercalli scale very much. It's often used by the government to determine whether a city will get federal aid or not. But in science class, we'll typically use the Richter scale instead of the Mercalli scale. A tsunami is a surface wave caused by an earthquake under the ocean. In short, when you have an earthquake on the bottom of the ocean, you have water that moves very quickly, and this generates a powerful wave. So when you have an earthquake on the bottom of the ocean floor, it will rapidly move the water either up or down. This will start off our wave. Now, out in the middle of the ocean, if you look here, you'll notice that the wave height isn't that big. The wave length, however, is much larger. So in the middle of the ocean, the wave height might maybe be a foot high, but the wave length will be miles wide. As that wave approaches the land, the front of the wave will start to drag on the bottom of the ocean, and the front of the wave will slow down. The back of the wave is still traveling up to 500 kilometers per hour. So the back of the wave catches up to the front of the wave, and this will generate a high wave height. A common misconception is that a tsunami is just one wave. However, there are multiple waves, and sometimes you can get tsunamis that last up to an hour. Another common misconception is that tsunamis are always big. Sometimes a tsunami can only be 6 inches high. A tsunami is just a wave generated by an earthquake, so tsunamis can be really small or really big. Here we have an animation showing how tsunamis form. We have two plates coming together, and the pressure will build and build and build and build until finally they break and snap apart. This will cause the wave to start. It'll head towards the land. The front of the wave will start to slow down. The back of the wave will catch up, and this causes the wave height to get large. Earthquake safety. It's always good to know about the area's history, so if you plan on moving to California, it would be a good idea to understand earthquakes. We do get earthquakes around here, but usually they're not going to be very big. The biggest problem with earthquakes are that anything heavy can fall down and hit you. It's not necessarily the shaking itself that kills people. It's usually objects falling on top of people. So, in terms of earthquake proofing your home, you put heavy objects down low. So, for example, in our classroom, we have our TV hanging from the ceiling. That isn't something you would find in California. Hot water heaters and gas appliances. They should be secure so that the gas lines broke. The problem with the San Francisco earthquake is that the gas lines broke and they started fires. And last, keep away from windows and anything that could fall on you. Earthquake-prone areas will build buildings to resist earthquakes. There's two ways that I know of that they can do this. One is they alternate rubber and steel. This allows the building to move back and forth and sway. This is a good thing. If you have buildings that are very rigid and resist change, they're the ones that are going to fall down. So you want buildings that can move and sway. Another way they allow them to move is by actually allowing the building to lift off the foundation a little bit. And they can sway back and forth. Good example of this, if you've ever been either on a bridge, either walking over a bridge or stuck on a bridge, and cars are driving by, you can feel the vibration, you can feel the bridge shaking. That's a good thing. It's when the bridges are very rigid and not moving, that's when you need to be worried. Another example, if you've ever been on top of a high skyscraper, on a windy day, if you actually pay attention, you can feel the building swaying back and forth in the wind. Again, that's a good thing. On a small scale, if you've ever climbed a tree to the top of the tree, you'll notice trees sway back and forth. That's a good thing. If those trees try to resist the change, they'll snap and break. Scientists can't predict exactly when an earthquake may strike, but sometimes they can get some data that will tell us that pressure is building up. They do this by using lasers to measure very small movement in the crust.